Hi, I'm Pat Kelly. Okay, in this problem, we're asked to find the particular solution to this differential equation given this initial condition. So we have a little bit of work to do. We're going to have to find first the general solution to this equation, which will take a few steps. And then once we get the general form, we'll use the initial conditions to get the particular form. Okay, so I've got some steps lined up here. I just want to kind of go through them. The first step for me for this type of problem is to make sure that the equation is in standard form for a first order linear differential equation. That just comes down to the y prime being alone, and on the right hand side there are no y expressions, so we're good. So I always want to make sure of that first. That leads us to the second step then, because from this standard form we can pluck out the p of x and the q of x. The p of x is always just what's being multiplied by the y. That might look a little goofy, but there's like a coefficient of 1 right there. So the p of x in this case is just 1. The q of x is whatever is on the right-hand side of the equal sign. So in this case, 6e to the x. I've done a few of these problems, so hopefully getting your p of x and q of x you're getting the hang of that. Next thing I would want to do is find my mu of x. My mu of x by formula equals e raised to the p of x dx. We've been using that formula for a bit too. In this case then, e raised to the p of x is 1, so it's just dx, which is just e to the x. I'm already to my third bullet here, u of x equals just e to the x. So I'm ready for that last bullet of finding y equals. Y equals another formula that you should be familiar with is 1 over mu of x integral q of x mu of x dx. Now we're just putting the particulars for us into this formula. This equals 1 over our mu integral q, which was the 6 e to the x, and then mu of x again, which is our e to the x, and then dx. Clean up just a little bit. I would pull this constant factor of 6 out. And then just a little bit of algebra, but always be careful with your algebra. E to the x times e to the x, you're adding exponents, so we would get 2x dx. Now with that integral, we can evaluate. We still have the 6 e to the x out in front. And this evaluates to 1/2 e to the 2x plus c. Okay, and I'll clean that one up just a little bit because I think I'd want to distribute through the parentheses and make it look a little simpler. So I would have 3 over e to the x times e to the 2x. And then plus this c times 6 is just a constant. Again, let me also bring up that e to the x and write it as e to the negative x. But I was talking about the 6 times c being another constant. This is just where I would backtrack and put a subscript of 1 on that c because it's different from this c. Okay, so this is looking good, but I could do just a little bit more cleanup with that e to the x in the denominator and then e to the 2x being multiplied by it. And that's just 3e to the x plus c e to the minus x. So I kind of ran for a while there that way, but I have my expression now for y that I want to bring back here and write as my general solution to this equation. 3e to the x plus c e to the minus x. Okay, if I take a breath right there, we've done good work in terms of finding the general solution, but this problem's asking me for the particular solution given this initial condition. So I'm going to come over to this initial condition that they give me, and I'm going to take with me the general solution. So we're going to use that general solution, y equals 3e to the x, I'll peek down there, plus c e to the minus x. I use that general solution to find the particular solution by plugging these specifics in. The specific value of y equals 3, I'll put there. And the specific value of x equals 0, I would put there and there. All right, so let's plug those in and simplify. The y is 3. That was this one. 3e raised to the 0 power. And that was the x value that they gave us. Plus c e to the minus 0 power, which was that x value they gave us again. I'm trying to keep the color coding up for you there again, just because there are a couple different 3's, and you want to make sure you see which one came from where. Now we'll evaluate. 3 equals e to the 0 power is 1, so we just get 3. Plus c multiplied by e to the 0 power, there's another 1, so we get plus c. I'm solving for c. I'll subtract 3 to the other side and get c equals 0. With a particular solution that we're trying to get, we're just solving for that value of c, so I can go back to my general form and put that value of c in. So now my particular solution that I wanted is, I'm looking at that general solution, y equals 3e to the x. I'm looking at that, but I'm trying to plug this value of c in. It's 0. So 0 times that, I wouldn't even need to write. So this would be my final answer. A little bit of work, but we got there, and that'd be the answer I'd be looking for in this case. Okay? Thanks very much. Hope that helped.